What if a neutron star, one of the densest, most extreme objects in the universe, passed dangerously close to our solar system? Not colliding, not even touching us, just passing nearby. In the very first moment we detected, astronomers realized something unimaginable. A city-sized star, heavier than our sun, and packed tighter than anything in nature, is drifting toward us at thousands of kilometers per second, bending spacetime as it moves. And here's the hook: before it even reaches the outer solar system, Earth begins to feel its presence. Our planet is still millions of kilometers away, yet tides subtly shift, satellites drift off course, and gravitational instruments around the world start giving impossible readings. The distortion is small at first, but growing, hinting at a cosmic force approaching that we cannot see with our eyes and cannot stop. As the neutron star enters the Kuiper belt, the solar system reacts violently. It pulls comets out of their ancient orbits like dust in a tornado, hurling them inward at terrifying speed. Thousands of icy bodies begin falling toward the sun, lighting up the sky with streaks of fire. But this is only the beginning, because the neutron star, as gravitational field, is so intense that it twists entire orbital paths as if they were soft wires. Neptune and Uranus wobble. Saturn's rings ripple like waves in a storm. And here is the part almost no one realizes. A neutron star's tidal forces are so strong that even from millions of kilometers away, they can stretch and compress planets just enough to destabilize their structure. Earth begins experiencing subtle seismic tremors. The mantle shifts. Volcanoes become more active. The crust, usually rigid and stable, responds like something under stress. Humanity, meanwhile, watches the sky as a faint, flickering blue dot grows brighter each night. When the neutron star reaches the region around Jupiter, the solar system enters chaos. Jupiter's orbit distorts by fractions of a percent, small enough to be measured, but large enough to cause devastating downstream effects. Moons shift into new paths. Tidal forces inside Jupiter itself increase, generating storms larger than anything ever seen. Asteroids between Mars and Jupiter begin breaking apart, pulled in two directions at once. Earth is still far away, yet the gravitational tides reach us with increasing force. Ocean tides rise unpredictably. Fault lines respond violently. GPS systems fail because spacetime itself is being warped by the neutron star's gravity. And here's the mid-video hook. Even if the neutron star never comes anywhere near Earth, its gravity alone can destroy civilization. When it drifts between Jupiter and Mars, debris from the asteroid belt begins scattering toward the inner solar system. Earth becomes a target in a cosmic shooting gallery. Meteor storms intensify. Impacts increase. The sky glows night after night as fragments burn up in the atmosphere. But the greatest danger is the neutron star's gravitational influence on the sun. As it passes, it distorts the sun's outer layers, triggering solar flares and powerful radiation bursts. Earth's magnetic field struggles to shield us. Communication networks flicker and fail. Power systems collapse. Satellites shut down. Radiation levels spike in high altitudes. By the time the neutron star reaches its closest approach, perhaps somewhere beyond Mars, the solar system is in complete turmoil. Planetary orbits are stretched into new shapes. The asteroid belt is half destroyed. Comets fill the inner solar system like a storm of icy arrows. Earth's orbit may shift by even a tiny amount, but even a 1% deviation would alter seasons, climate, and long-term stability. And then, as silently as it arrived, the neutron star drifts away, leaving behind a solar system scarred for millions of years. The planets would settle into new orbits, but Earth would never return to its old stability. Climate patterns would shift permanently. Lunar tides would change. Orbital resonances would never be the same. A single neutron star passing nearby wouldn't collide with us, but it would rewrite the structure of our entire planetary system. So what do you think would be the most catastrophic part of this encounter? The orbital chaos, the cosmic debris, or the gravitational distortion of the self? Drop your thoughts below and let's explore the next impossible scenario together.